announcement here for the relative to the webinar today. We've got a couple of agenda topics we want to talk about. One being, Rick's going to give us a quick debrief of the steering committee meeting that took place on February 13th here at Bismarck. In particular, some of the topics they covered relative to our ongoing research and the proposal recommendations that we forwarded to them and how they handled that given the sequester and continuing resolution. And then we're really going to be blessed because Bill Gerla is with us today with the Nature Conservancy talking about some of the work that he and his team have been working on over at Glacial Ridge National Wildlife Refuge relative to some of the hydrology issues that they're dealing with over there and restoration of that particular landscape. Particularly, Rick, I'm going to turn it over to you here for the steering committee discussion. Take it away. Well, we're not going to go through these in too much detail with the exception of one of the items. So just an overview of the topics that were discussed at the steering committee meeting. And you can see those on your screen right now. I'll mention a little bit about a couple, but the first one you can see is surrogate species. Many of you know that the service is undertaking plans to develop surrogate species for conservation use. There's been a lot of discussions going on, particularly with the states about surrogate species, and at the point we're at now is that the agency will be working with the states via their state wildlife action plans to try to come to some agreement on surrogate species and selecting surrogate species for us, and then also to include probably some of those state species, which is a little bit of a change from kind of where we were. But Tom Elias, who's our regional director, gave a quick overview of where we are. There's a technical guidance document out for review. Those comment period is open till the end of March. So that was just an update from Tom for the benefit of the group on where we are. Communications is always a standing agenda item, and Ashley provided us with an update. We are upgrading our website, and there'll be more information coming out about that soon. It's going to be a really neat upgrade with some features that'll make it very easy to use and very easy for everybody to put information on as part of our group. It will also be really easy for the public to access information that we're producing. And then we have produced an annual report. All the LCCs are doing annual reports this year, and we've produced one that is in review right now. You all on the tech committee had a chance to review that. The steering committee also has had an opportunity. We'll be finalizing that. As soon as it's final, we'll get you everybody copies of that. We had an interesting presentation from some folks in Alberta that I've been working with. As you all know, Manitoba, Alberta, and Saskatchewan are part of the LCC. Ian Dyson and Bill Dolan gave a really interesting half an hour discussion of kind of an overview of what they're working on with the Prairie Conservation Forum in Alberta, another group called Water for Life. And just to kind of summarize, I think the most interesting part of that for me, or what struck me, was that they did say that the information that they're developing for fish and wildlife from a conservation perspective is being readily used by planners that are doing city planning and rural planning and business development planning. They're actually taking that information and incorporating it into what they're planning to do for development, which I thought was pretty unique compared to how we do things down in this part of the world. So that was a quick overview of what's going on in Canada. I'll be doing a webinar for them on some of the things that we're doing in the LCC here in about another 3 weeks. One of the significant one, I think, too, we've talked in the past about trying to get our steering committee to engage a little bit more, to think more forward about the future of the LCC. So we included the next agenda item, which I hate to use the word strategic planning too many times with those guys, but we did. And the interesting part of that discussion was that the steering committee was agreeable to start having discussions about like a workshop or a retreat or a forum to begin engaging in providing a more strategic direction for the Plains and Prairie Potholes LCC. That kind of came out of the agenda item related to budget, but I think they all saw the need to given the conditions we're under with budgets and everything else, really start to put some meat on the bones of a long-term vision for the LCC. The last agenda item is going to talk about budget and where we are with the 13 project funding and the projects that we received for this latest round of RFP. So what you see on the screen in front of you now are a list of things that the steering committee tasked Mike and I to do to get them information so that they could further discuss how to proceed with the ongoing projects. And as you all remember, we have a pretty huge funding tail, and there are 6 of those projects that we've committed to over the years that this year, had we not had a CR and sequestration, we could have funded those things, but it wouldn't have left us much money. Now, given the CR and sequestration, we're kind of in a pickle with having more projects on the table than we can continue to fund. So Mike and I have pulled this information together and provided it to the steering committee, and they're going to review that here, and then we'll get some further direction from them on how to proceed. But in essence, I think we just go to the next.
Well, one thing I might mention is we've talked to all the PIs for those 6 projects, and we got some terrific assistance from 4 of those folks to trim their budgets back for this year to try and free up some funds, make sure we're under budget for our obligations, and maybe we can get to some of the new work. But really, kudos to Bob Greswell and Doug Johnson, Maureen Gallagher, and I'm missing one. Oh, and Robert Gleason for helping us out. And I think that brings us to what the potential is for new work.
So one of the things, the other part of this is we had an RFP, and there were 4 projects that kind of came from the tech team, recommended to the steering committee. And in essence, they're on hold right now until the end of March, till we find out if anything's going to change with the CR. We are talking to those project leaders, PIs, to see if they could delay it until 14. One of the issues the steering committee is going to have to deal with is the voluntary budget cuts that Mike mentioned from the ongoing projects, which could get us to a place where we could fund them. The expectation from those folks, almost all of them, is that they would receive that money back in 14. Well, if we do that and delay these projects till 14, that really puts our funding tail out there even more. But so the message, I guess, here is at the end of March, we will know more about where this is going to go, and we'll provide all of you with whatever decisions the steering committee makes regarding how we're going to approach funding these ongoing projects and any new projects. So with that, I'll just ask if there's any questions quick about that, and then we'll move on. And hearing none.
We'll give folks a couple more seconds. Anybody have any questions for Rick or myself about the budget issues and hoops we're jumping through right now? And we'll do our best to try and answer them.
Are you thinking? This is Rebecca Phillips. Hi.
Hi, Rebecca.
Are you thinking that the 27th or somewhere around there you'll have a pretty good idea?
Well, we don't know whether we're going to shut the government down for one thing. So yeah, we should have a pretty good idea. I would think by then we'll know what the sequestration traction is going to be for the rest of the year, and whether or not Congress is going to act on a continuing resolution perhaps for the rest of the year, and then we'll have some firm numbers.
Okay.
That's our hope, and Rebecca, thanks for being patient.
No worries.
Rebecca, this is Tom Milius, one of the co-chairs of the LCC, and I enjoyed listening to the rundown that Rick and Mike presented. I plan soon after the 27th of March to have an opportunity to visit with Terry Steinway and Mike and Rick, and we should be able to move forward one way or another depending on actions that Congress will take. So hang in there with us, and hopefully more clarity will come at the end of the month.
Fantastic. Thanks.
And I don't know if Johan Walker is on the phone or not, but we are looking at some potential alternative funding for that particular project. It may qualify for some EPA funding, so we're trying to find some ways to patch this all together. And as Tom said, appreciate all the PI's patience with this process, but we're plugging away and doing the best we can. What's next?
Well, we kind of went over this. Mike and I have completed those tasks assigned by the steering committee. Mike's contacted those 4 PIs from the recent RFP, and then, as Tom mentioned, by the end of the month we'll know more and we'll be able to make some decisions and let everybody know where things stand.
Okay, I think with this, hopefully you're still with us there, Phil.
Yes, I am.
I will transfer all this over to you. And on your desktop there, you should see the box that says share my desktop.
Okay.
And the floor is yours.
Okay, well, thank you very much. And thanks for the opportunity, Mike and Rick, to say a few things about the work that we've been doing at Glacial Ridge and actually elsewhere. I include a picture of myself. I know that many of you on the call don't know me, and picture is much better than if it were video.
No, I'm not sure we're seeing it yet. At least I'm not seeing your desktop yet.
Oh, okay.
Did you click on that share my desktop?
I bet that's something that I missed. Hang on just a second.
I think we're getting there.
Okay. Should be on now?
Yeah, that looks better.
Okay, sorry about that. Just a quick overview of what I'd like to talk about this afternoon for a little bit. Groundwater-dependent ecosystems are really important in the upper Midwest and in the plains. And in our region, we have the semi-humid to semi-arid conditions and really variable continental climate. A result of that is that it takes a really large recharge area to create small discharge zones. And these small discharge zones tend to be just scattered across the landscape then in various areas. And they provide really an unusual niche and refugia for various species and habitats. And part of the issue is that these discharge zones tend to be quite consistent in their soil moisture and more consistent in their temperature than elsewhere out on the prairies or the plains. The groundwater-dependent ecosystems are perhaps best known as Fens, but there's a lot of uncertainty in the meaning. So what I'd like to do is just go through a few definitions at first, and then give some general examples of groundwater-dependent ecosystems, and then focus in on a couple of examples from Glacial Ridge. The next slide shows some of the definitions of Fens, and it varies geographically, but generally for the Midwestern United States, they're fairly consistent. I think the earliest I found was one by Curtis in 1959, describing wetlands in Wisconsin, and he describes Fens as being wet and springy grassland with the internal flow of calcium and magnesium-rich water, which would be hard water, basically. And then more recently, Ammon and others in a paper that appeared in the journal Wetlands had 4 components to the definition. One is that they're groundwater-related root zone saturation. They're rarely, if ever, inundated, so they're wet but never flooded. And they have a carbonate or carbon accumulating substrate, and they're characterized by graminoid or grassy vegetation. So that's a little bit more specific. And then just right after that, Bedford and Godwin in 2003 described it in a little more general terms for what we're calling Fens as having constant groundwater saturation in the root zone. And then the other is that the water composition reflects the mineralogy of soils and sediments. So there's a bit of variability in that, in the definition of Fens. So for groundwater-dependent wetlands, I'm going to make a distinction. I'm going to call them groundwater-dependent wetlands because Fens tend to take on a little bit more of a focused definition. In fact, Ammon, interestingly enough, in their paper, they went out and they examined things, sites called Fens from there, rather than coming up with characteristics and then trying to locate those types of conditions. But the groundwater-dependent wetlands, of which Fens are a subset, provide this important ecological niche. More importantly, they're really difficult to protect and restore, partly because of the fact that they are groundwater-dependent, and the groundwater is more difficult than, in many cases, to determine the source and the flow lines and so forth. And then what I want to spend a few minutes with is to just describe some of the variability in space, time, and character. On this slide, you can see some of the species that occur in groundwater-dependent wetlands. And then over on the left-hand side, tile drainage, surface water drainage, and land use can very easily disrupt and quite literally destroy fens. The photograph toward the bottom in the left is a fen in southeastern North Dakota that was allowed to be grazed, and it really destroyed the vegetation and really changed the surface features of the fen itself. So in terms of the large range in size, and this is where I feel like I'm going off on a limb, but I'm going to try to go from large to small in this case. And between Grand Forks and Grand Forks Air Force Base, you can see kind of a shadowy area in the aerial image. And the distance between the Air Force Base and Grand Forks is about, I think it's about 12 miles. And right in the heart of that shadowy area is Kelly's Slough National Wildlife Refuge, where there's a lot of groundwater discharge. That shadowy area is actually a wet saline prairie that's a result of groundwater flow coming from pretty distant areas. The glacial sediments and some of the Paleozoic bedrock that occurs beneath the area between Devil's Lake and Grand Forks, and that water picks up a lot of dissolved minerals before it's discharged in the Red River Valley. Notice the cross section in the bottom shows the nature of the water composition. It varies quite a bit, and that profile is about 100 miles wide. Now that's only a piece of perhaps a broader area, and that broader area would be looking at a cross section through the Williston Basin. If you focus your attention over on the right-hand side, the discharge zone is shown in the last slide. The Williston Basin is about 550 miles in diameter, and it's a very complex, multi-layered system of aquifers and confining units. And then down at the base, there are saline formational waters or connate waters, which are not very mobile at all, but there's enough salinity that works its way through to be discharged in the Red River Valley. Now, perhaps that's a stretch calling that. It's certainly not in the normal terminology of calling it a fen, but the saline wetlands in the Red River Basin certainly are a groundwater-dependent ecosystem. Now, on the other end of the spectrum are groundwater-dependent systems that tend to be very small. And Juneberry Fen is a fairly large feature. It covers several square miles up in northwestern Minnesota. And it's an expansive sedge prairie. Over in the lower right-hand corner, it shows a photograph looking across the fen, and there's some Phragmites reed in the front that are related to a ditch that was put in about 100 years ago. There's very poor drainage. And more importantly, there's no topographic driver at Juneberry Fen. In other words, there aren't higher areas around it that allow groundwater to flow. So I believe what's happening in Juneberry Fen is that you get this vertical hydrodynamics. There's kind of a push and a pull, as shown in that animated GIF there in the upper right, where when it rains, the hydraulic head changes so that the groundwater is actually moving upward and downward, and it's cycling. And that may occur for decades, perhaps even centuries, and to kind of begin to develop characteristics of groundwater that actually has flowed through a long path line. So although Juneberry Fen in most mines wouldn't really constitute a fen. It does because of the vegetation and the nature of the composition of the groundwater. But spatially, it's really taking place only at one small point. So it's very much in contrast to, say, the larger system in the Red River Valley and the Williston Basin. There's also a large range in age, and this is an image from a carbonate-rich spring in the driftless region of Wisconsin. And this spring was probably present during the maximum extent of Wisconsin glaciation 21,000 years or so ago. And it's still there, it's still developing. Some of these tufa deposits, as they're called, these calcite-rich deposits around springs that have built up over millennia. And then another older system would be the Lawndale, Minnesota Springs and Seeps. And over on the left-hand side, the aerial image shows nothing really jumps out at you, but when you plot it up with the LiDAR elevation colored, it's very promising bullseye-shaped features, which are springs. In fact, you climb up to 3 to 6 meters of relief up to the top of one of these, and water's bubbling and flowing out of an orifice at the top. Really unusual features, and I haven't seen anything quite like them in the literature. My guess on their origin is shown down at the bottom, where these probably developed during and perhaps even prior to Lake Agassiz. And as Lake Agassiz covered up the spring, these began to develop actually somewhat aqueously below the lake level from groundwater that's flowing through intercalated till and sand and gravel intercalated within till off to the east. So these are probably quite old too. Now again, I'm going to stretch it a bit, but fen-like features or groundwater-dependent ecosystems or groundwater-dependent hydrological systems can be quite recent too. And up at the top, it shows some saline seeps in eastern Montana. These also occur in the western Dakotas, and they're a real problem because they ruin really good farmland. The origin is probably related to cultivation and agronomy, where land is allowed to lay fallow for a year or two to allow moisture to be recharged to increase the soil moisture. That, at times, is so great that recharge to the water table in the groundwater system begins. And over in the upper right, you can see a diagram where you have recharge occurring, elevates the water table, and then that dissolves some of the minerals, and then it precipitates in the saline seep. They're definitely a problem, and it would be kind of a hard push to sell these as an important ecological feature by any means. But interestingly, looking at the two diagrams, the one in the upper right, and then the diagram from Amit's paper from 2002, they're basically the same kind of a system. You have a recharge area, you have permeability, you have recharge to groundwater, and then discharge at a low elevation point. The point that I want to make with this is that there's a spatial variability and there's a time variability included in all of these. And then there's also a certain degree of complexity that goes along with it. This is a schematic map showing the Piesic Fen, which lies about 40 miles northwest of Grand Forks. And it's a couple of miles west of a little town called Piesic in the Red River Basin, in the Red River Valley. And it lies at the foot of the Edinburgh Moraine. And the Edinburgh Moraine is relatively recent, so it's a late glacial deposit. It's an ablation hill, meaning that the glacial front sat there for quite a while, and sediments were delivered to that ice front over a relatively long period of time. Back to the west is the Fortville Aquifer, which sits at a higher elevation. And I believe what's happening here, there isn't much in the way of core or other evidence, but I believe what's happening is that the Edinburgh Moraine in this position covered over outwash deposits which are continuous with the Fortville Aquifer. And that water then can move through those outwash deposits to be discharged at the base of the Edinburgh moraine. Now, if you were to just look at the surface watershed, that's shown in the magenta color of the pink. Very small, and it wouldn't contribute at all near as much water as what the actual capture zone involves, and that goes way back to the Portville aquifer, which also includes the capture zone and the surface watershed that supplies the Portville aquifer. So it's pretty complex to sometimes work out the details of just where that water comes from. So I guess at this point, maybe I should just take a break and ask if there are any questions before I go on with Glacial Ridge example or comments.
Any questions for Phil?
Okay, so let me go through a couple of examples of fen or groundwater-dependent wetlands that we've been working with at Glacial Ridge. Glacial Ridge is a 25,000-acre restoration project that began in 2000 with the purchase of that land by the Nature Conservancy. And just last year, most of the restoration has been completed, and the land was turned over to the Fish and Wildlife Service. It's an important area. It has this contrasting wet and dry habitat. It's these linear wetlands and linear prairie, in some cases quite dry prairie, which are related to beach ridges on former Lake Agassiz. And the wetlands and these prairies are valuable because of the occurrence of orchids and calcitoid species that occur within the wetlands, and also migratory birds. The area was drained and ditched between 1910 and 1990 very effectively, and much of the area was put into cultivation. So the restoration project was quite large and involved. For example, over 110 kilometers of ditch were filled in the process. The hydrogeology of the site is shown in the cross section. The cross section is roughly about 5 miles wide. The vertical scale is greatly exaggerated, and it shows these beach ridges as shallow sources of recharge. And then to complicate matters a little bit, there are buried outwash aquifers below that contribute groundwater or may actually be recharged by areas within the beach ridges. And there are two sites, I guess, that I'd like to take. This first one is along the western margin of Glacial Ridge, and where it butts up against the Pemmican Trail Preserve. And we've been monitoring there since 2003. The Chintown Beach Ridge cuts the area in half here. So off to the east, you have higher elevations where it says Glacial Ridge Project, and you have recharge occurring. And then over on the left, it tends to be wetter within the Pemmican Trail Preserve. And then in between, there's a fen or the saturated zone that hosts calcitoid species and small white orchids and so forth. Well, the dots show groundwater monitoring wells. Most of those are pretty shallow. And two in particular that I want to focus in on. One is in the former cropped area, and the other is in the native. In the native, the Pemmican Trail Preserve was first set aside in 1975. It's never been cropped, and prior to 1975, it had been grazed on occasion. The cropped area had been cropped right up until the year 2000. That area was planted with native seed in 2001. My fear, I guess, going into this in 2002-2003, when I first started working for the Nature Conservancy, was that the area that had been formerly cropped and planted with native seed, I was afraid that the native species would dry up the landscape and perhaps dry up the fen, which is actually quite important. That was a concern, and that's why I began monitoring groundwater out at that site. Perhaps just to jump ahead, it turned out okay because the fen itself was receiving groundwater from deeper sources, but the concern is a valid one, and the monitoring results are quite telling. So they kind of sketch this out. Why does this happen? Over on the left-hand side, it shows cultivated fallow ground. And under those conditions, you have you have some evaporation from the surface, but the root zone tends to be quite shallow, and the period of senescence and the period in time which the crop is out of the ground is fairly long compared to perennial grass and forest, where the evapotranspiration is greater because of a deeper root zone, more carbon in the soil. It tends to store that water a lot more effectively. So the end result is that you have less recharge occurring following the restoration. And with that less recharge, there's going to be lower groundwater flow, which down gradient may actually remove water from fen-like sites or groundwater-dependent ecosystems. And it turns out what we did is we've been monitoring since 2003. And this graph shows the results. They're scattered all over, as you might expect for an area out on the prairie. The gray diamonds show the former cropland, and this is the one well, and then the native is shown in the green. The thing that really should stand out on this graph is that early on the well in the cropped area had water levels which were higher than the native. And then long about 2009, 2010, it flip-flopped where the water levels in the former crop zone dropped continually, but the native wells, they remained relatively constant. And what really stands out is if you look at the difference between these two, notice that the difference is reversed as you go across, and the magnitude changes. And when you actually plot the difference, you can see that there's been a kind of a striking decrease in or at least a striking difference in the water level. So the negative values over on the right-hand side represent that former crop well with water levels that were above the native well. And then as you go into the positive zone on the right-hand scale, that's where the native well water levels were above or are above the former for the former crop area. So there's quite a switch in the conditions. Now, I guess the summary of that is that my fears initially of having that restoration go forward were true, that it would dry the landscape out. The fortunate thing is that the actual fen itself is receiving water from deeper sources. And I won't go into it today, but we do have some geophysical data that shows indeed that there is a sandy unit that lies shallow beneath the fen, and that's apparently what's feeding and maintaining the water in the fen. So the fen wasn't damaged by the restoration. Now, looking at this is the final example. This is the Herman Beach fen. This is in the southeastern part of Glacial Ridge. And this is a little bit different situation because here the fen was annihilated. It was very much damaged, unlike the other examples. And here we were interested in attempting to restore the fen. Over on the left-hand side, in 2003, it shows a dugout, and it shows to the west of the dugout a ditch. That area had been cultivated, and the dugout itself was used for grazing purposes as a water source. Also towards the bottom of the image is County Ditch number 72, which drains a large area above Glacial Ridge, and that used kind of a depression along the beach ridge, but it was excavated quite a bit deeper than the original drainage level. So we had a number of elements of the restoration. We filled the dugout, we filled the ditch, and restored a pothole that the ditch had drained. We raised the ditch level on the south, ditch number 72, raised that level and held the water back with a weir. And then in addition, there was some tile to the east or to the right-hand side of the beach ridge, which maintained a low water table that cut water off from flowing through the beach ridge. So over on the right-hand side, in 2010, it shows that broken tile, the recovering fen, and the restored pothole, and the fact that we filled the dugout. So what's really important here, though, is the next slide, and this shows the features really come into play here. One is that that the water table tends to be much deeper now where the fen had been, meaning that we're getting this break and slope in the water table, which is important because the break and slope is indicating a discharge that's occurring at that point. So we've been able to get the discharge to occur, and the water table has risen down below, and it has risen up above, and then over on the right-hand side, it shows the change in the water table. So we actually are able to lower the water table where the dugout has been, get that back up to the surface, the regular surface, rather than having it above it, and then also maintain a higher water table both above and below the original fence. So the restoration, I think, has been really effective in restoring these more natural hydrological conditions at this point. I guess just to summarize, that was a couple of examples from Glacial Ridge, but these groundwater-dependent wetlands, they vary greatly both spatially and temporally, and sometimes I think we don't recognize the difference between them, that there's a large continuum, and that fens are a subset of them. I went through the Glacial Ridge example for Pemmican Trail fen. The source of water is really hard to determine because it's deep, you don't quite know what that might connect to, but our monitoring shows that groundwater restoration really reduces the recharge and may indeed affect the downgrading groundwater-dependent ecosystems in other cases. The Recurrent Beach fen, it was largely destroyed through agricultural practice, but at this point the hydrology and to some degree the natural community is now recovering. So, I guess the take-home message is that we need to understand and know the boundaries of recharge before we begin to think about restoration. We have to understand the capture zone and recognize that the changes in land cover in the recharge zone will affect hydrology. And then finally, we don't have time to go through it today, but I also have recognized in some of the work that I've done that land cover and the sediment soil substrate can really affect water composition. So actually changing land cover can change water composition, which in turn may change the nature of the habitat. And I think with that, I'll end and ask if there are any questions or comments.
You still with us, Jeff? Sure. You have anything for Phil? I'll give you the first crack at it since we finally had a talk that's right in your lane.
Well, I find the hydrology story interesting and comparable to what I've been hearing. But the addition, I think, Phil, which is great, is some longer-term information, which kind of substantiates the theories that some of us had. But, you've got a water-centric benefit story here relative to, maybe wildlife. And I guess one question I have, a non-water question, is there's tremendous benefits to native prairie, and obviously one is resilience of climate. And you didn't say much about the benefit of the actual native prairie to wildlife. I don't know if Nature's Conservancy is looking at that, or if you got other colleagues that are looking at that aspect. But it is interesting what you say about, the oscillation of restoring the fen. But do you have any comments on the actual upgradient restoration?
Well, it's part of, I guess, the way that I look at it is that it's part of a larger system, and the hydrology is interconnected and integrated with what goes on in those in the upland prairie. And it's I feel it's really important that any kind of planning that goes forth or restoration that goes forth with upland prairie takes into account how that might be affecting recharge. There's perhaps my information might be a little bit anecdotal with the situation at Pemmican Trail, but there are other examples in the literature where the restoration of prairie heads dried out potholes and it's really affected the hydrological cycle. And it's something that I don't think is taken into account very often, and should be, that in certain circumstances there may be changes to that hydrological cycle that really hydrological budget that really aren't taken into account.
Sure.
Hey, Phil, it's Rick. I have a question for you about this work. So as I'm listening to you talk and thinking about the recharge discharge and some of the impacts. One of the things that struck me, I'm trying to think how to say this carefully, but if I was a drainage board guy and I was looking at this information, or I was pitching pattern tile drainage and ag stuff in the valley or anywhere else, I mean, how do you respond to what I think is going to be a misuse of this information, certainly, but I can see it going down this road. Well, you restore those prairie, you're going to negatively impact our groundwater.
Well, that's a really interesting question, because one thing that I did notice at Pemmican Trail, I was monitoring soil moisture there also, and found that that when it became really dry, there was higher soil moisture in the native prairie area, which came as kind of a surprise to me, because it seemed like, if it got really dry, then there's going to be no moisture. But in reality, the little bit of data that I collected showed that the native prairie tended to go into senescence in a very effective way and pull that moisture back, so that under really dry conditions, that natural cover tended to protect the soil moisture, whereas in the crop areas, that soil moisture was lost. So
I assume it would capture more snow as well.
Oh, absolutely, yeah.
So the reason this question interests me is the PPP-LCC has funded another project that was an economic analysis that looked at, in essence, healthy ecosystems, healthy local economies. So one of the pitches out of that is that these types of restoration projects, as a part of a diverse portfolio, can provide numerous benefits. And based upon what you just told me, I mean, there's one right there that I think could be easily used in a pitch for more diverse ecosystem services that currently exist to be followed up the planet.
Hey, Phil, Jeff mentioned the resiliency afforded by some of this restoration, and you mentioned the drought that we were in the last year or a couple of years. What can you say about the discharge rates and maybe some of that resiliency in the last few years?
Unfortunately, I tried to have some of the soil moisture results from Pemmican Trail published, and the problem that I had is that I didn't have enough data. It turned out to be anecdotal. You couldn't really work with it statistically. And the surface water monitoring that I've been doing has been primarily on Ditch 66, which is influenced by the gravel operation. So the challenge is finding a place, a kind of a natural outdoor laboratory where you can have controlled conditions and be able to actually gather the numbers and collect the data that are needed. So for the future, it's something to keep in mind to find a good place to actually show some of these things, because I have a feeling that those advantages really exist, but that it's going to take some effort to actually demonstrate it conclusively.
So, if I could interrupt, this is Rebecca Phillips. Yeah, Phil, it's been a long time.
Yeah.
I just thought I'd mention that I have a native grassland outdoor laboratory kind of area that, when it is fully instrumented, where I'm measuring evapotranspiration and soil moisture and carbon fluxes and everything, and I'm comparing that to a crop field area. So I haven't worked up the data yet, but I do have over 3 years now of interesting results that would probably support what you're talking about, where you look at the change in water use efficiency and things and under drought versus wet years, and like you say, when they hold the moisture better in the prairie.
Yeah, that's wonderful if you're able to collect those data, because I just haven't been able to set up the instrumentation to do that at Glacial Ridge because of all the disturbances there.
Yeah, it's a hurdle to get it all set up. I know.
Oh yeah.
It's worth. This is Josh H. It's worth noting as well that this is only some of the work that Phil's been doing at Glacial Ridge. He's also been looking at water quality in groundwater and making some really interesting discoveries with that component of the hydrology as well. And this is also part of a larger cooperative project with the USGS, and a lot of this work was funded with seed money from this LCC, and so it's great to see some of these products start coming out. But Tim Cowdery with USGS is working on kind of a larger water budget for the refuge as a whole, and then our idea has always been to extrapolate out those results to other potential restoration sites across Minnesota or within the PPP. So it's worth noting too, there was an economic impact. Billy did his economic impacts review of Glacial Ridge after the restoration and wrote that up. It did not take into account those so much the water quality benefits. For example, the city of Crookston contributed money to these monitoring efforts because they were so concerned about their groundwater supplies and the nitrates, and Phil has done some, like I said, really interesting work into those aspects as well. So there's a lot of things going on at Glacial Ridge that Phil and Tim have done, and this is all this great work on the fence is just kind of the tip of the iceberg.
Mm-hmm. Well, can I ask you a question? So it's sort of a different one.
Sure.
But I've got some here in the Prairie pothole region where I've done some work. I've got what I think are some really interesting large-scale data on basically the potholes using this DEM that's at a much 1 meter resolution DEM. It's not LiDAR. But, we've modeled it over several counties of land area. So we've got all of these basins where we could tell you the potential for storage, let's say, in cubic meters, and and surface water flow drainage lines. So it doesn't speak anything about groundwater, but my collaborator that was working on this with me, he went back to his home country, and so I'm at a point where I'm thinking, do you have any ideas on what you think are some of the pressing issues and ways that I might be able to leverage that data in a way that would be useful but wouldn't take a lifetime of work to do?
Oh, the question catches me a little bit off guard, but I think my first reaction to that is that in the prairie pothole, the hydraulic conductivity and the transmissivity of the tilts is really important. And in some places, you do have the traditional kind of a recharge, flow through, and then discharge system. But in other cases, I think that the permeability of those is so low that really groundwater is a very, very tiny component of the water budget.
Yep, I agree.
And so making some sense out of that and being able to map, especially using it as kind of a GIS environment,
right?
Being able to map out areas where groundwater is really an important component of the water budget versus those areas where surface water, you could probably with enough shallow geological and soils information, map out areas where groundwater is important and where surface water in turn is an important component of the water budget. That's my first reaction to the data that you've collected there.
So do you mean like saying literally poking holes around some of these areas where you think groundwater might be flowing?
You can certainly do that in field truthing, but using Sergo data, soil data, and a little bit of knowledge about the glacial history, the glacial sediments, you could probably come up with a proxy for that data, and at least make a first cut, and then be able to use some shallow subsurface drilling to see if it really works out.
Oh, I see.
Yeah.
Okay. Well, thanks.
I'm going to follow up a little bit, Rebecca, for everybody, but I have a specific suggestion for you too.
Sure.
In April, in our next webinar, Mike Antle from USGS in Northern Prairie is going to give a presentation on his work on wetland consolidation.
Mm-hmm.
But from what you provided, I think he would be very interested in the information you have, as would Chip Eulis, and probably Ray Finichario, who's working on some tile drainage issues.
Okay, and the first fellow you mentioned was
Mike Anto, he's over at Northern Prairie.
He'll be giving the webinar next month to tie into this one a little bit, and that's on the wetland consolidation work that Northern Prairie's been doing.
What is wetland consolidation?
You take all the little seasonals and temporaries and semi-permanents, and you tile them or you ditch them into the one big wetland you can't drain and fill them. And that's kind of a common practice in the Coteau area. But some of the information, and again, Phil stuff as well, I think might be interesting in the context of management relevant questions in terms of additional information that could be provided to people on why or why not to do that, and why or why not it would be economically feasible to do that.
Yeah. I use this in that regard in a restoration project where I tried to explain to the people involved how useful this could be when you're trying to restore wetlands, because you have an idea of what the flow accumulation is and where the water does flow. And it was interesting that it was not. It seems like it just wasn't well received by the practitioners. So I don't know what it is, but maybe because it's in GIS or something.
Well, I think this points out a pretty important concept, maybe for Mike and me especially, but this is another really good example of the benefit, I think, of the LCC. We're connecting various researchers with various data sets and various questions together. So, I think that's really important. We know a lot about some wetland systems more than others, I think. So, the information that you have, Rebecca, and what Phil has provided, I think if you talk to Chip and Mike and those folks, they'd be very interested in this information as well.
Okay, great.
And Josh has been actively involved in this as well. So, are there any other questions for Phil?
No, it's a comment. I got to get off the line, but thanks for the presentation, Phil. It's good to hear what you're up to. This discussion also reminds me that there's been some pretty recent research on prairie habitat and at the long-term environmental research site at Cedar Creek in Minnesota. If somebody probably familiar with that. U.S. Justice been also doing some work down there looking at not only water movement but chemical movement and what's the benefits of different crops compared to native prairies. So,
and on the other side of that coin, Jeff, as you know, there's a ton of information that the USGS and Fish and Wildlife Service and others have collected on the western end of the spectrum out at Cottonwood Lake Study Area by Jamestown.
Absolutely. Yeah.
So, I think we'll wrap up, folks. A couple things. Stay tuned for more information on our budget issues that we mentioned early on, and we'll let everybody know as soon as we know something and figure out a way to proceed. This is a pickle we're all in, and it's not a pleasant one, but we're trying our darndest to work through this effectively. Again, thanks to Phil for the excellent presentation and the really good questions from folks as well. Again, our next webinar will be April 3rd, and that will be Mike Anto from USGS Northern Prairie talking about his wetland consolidation study, and we'll send out notice on that as well. So with that, unless anyone else has questions or comments, I think we'll say adios for today.